This is going to be a short video about the receiver incremental tuning circuit. So that's now complete on the transceiver. And receiver incremental tuning is a mechanism that allows the operator to adjust the receive frequency while keeping the transmit frequency constant. So I can demonstrate that. I've currently got RIT turned on in the transceiver, and you can see that as I adjust the RIT pot, the frequency will go from 2.94752 down to 2.94428. So that's the receive frequency. As you can see, if I turn RIT off, the frequency will be constant at 2.94550. It's got to settle down a bit. So you can see that you vary the when RIT is off. You can both the transmit and the receiver is on the same frequency. With RIT is on, you can vary the receive frequency by a small amount while keeping the transmit frequency constant. So how does it work in this kit? And this particular kit uses comparators to achieve that. I've got a quick blow up of the circuit that shows those comparators in place. So this particular comparator is a LM393, and the way a comparator works is it has two inputs: the negative or the inverting, and the positive or the non-inverting. And basically how it works is, if the voltage at the inverting input is greater than the voltage at the non-inverting input, or the plus, then the output will be drawn to ground. If the reverse is true, the plus is greater than the minus, then the output will effectively be an open circuit. So when if the RIT is on and we're not transmitting, effectively we're going to get the situation where this pot is actually in circuit, and this one we'll have a grounded connection here. This one will be an open circuit, and this pot will be in the circuit. And this pot, by varying the pot, it actually affects the voltage at the anode of the varactor here. This is a MV2104 varactor. And of course, as you vary the voltage across a varactor, it changes its capacitance and thus changing the frequency of the VFO. Now, if RIT is off, basically this will be drawn to ground and this will be an open circuit. So when this is drawn to ground, it'll just have this fixed 5.1K resistor, and then you'll have a fixed voltage across the fixed voltage across the varactor here. So with RIT on, we have a 0 to 1.3 at the anode of the varactor. With RIT off, we have a fixed 0.788 volt at the anode of the varactor. So that's basically how it works. And as the capacitance of the varactor changes, thus the frequency of the VFO changes. So I've seen this comparator-based RIT in a couple of circuits. So it does seem to be a common pattern in these old school radios. So anyway, I just thought I'd do a quick video of the RIT in operation here. I'm still waiting on those parts that I mentioned. The edge connector is still coming. Hopefully it'll come next week. The other thing I have to get, and it's been hard finding these, is I need some crystals for the various bands that aren't in that much of a common use. There's a 15 megahertz crystal that it uses, an 18 megahertz crystal, and then a 22 megahertz crystal and 26 megahertz crystal. I've been able to find a source for the 15 and the 18. The 18 and the 22 I got from I've ordered from DigiKey. The 15 from another outfit online. 26 megahertz crystal I haven't been able to find anywhere. So I'll probably be out of luck for that band. I actually went to the Cowtown Hamfest yesterday. One of my main reasons was to search for crystals. Unfortunately, there weren't any of those sorts of crystals in there. So anyway, just a quick explanation of the receiver incremental tuning part of the circuit, and I'll post my next video once I get the edge connector in, which will hopefully be around the 22nd, 23rd of this month. So anyway, That's all for now. Catch you later.